Okay, some more transformations here then, just to sum everything up. So we look at a few ideas here. It says reflect triangle A in the x-axis and label your answer B. Okay, so obviously if you remember when you reflect, okay, in the x-axis, so each corner point, that's 2 from the axis, so we can go down to, that's 2, so we go down to, mark it there, and then that corner point then, that's 6 from the axis, so you go down 6, you end up here, and you can see then my corner points, I join them up, and I've got my triangle reflected in the x-axis, and it says for me to label my answer B. Okay. Now, some questions have more than one thing for you to do. It says then rotate your triangle B by 90 degrees clockwise about the origin. Okay, so get some tracing paper. You get this in the exam, of course, as I've mentioned before. It says reflect. What does it say? Rotate your triangle 90 degrees clockwise about the origin. Now, the origin, of course, is here. Remember, I put a cross there to represent my axes. So I need to then put my pen then, or my pencil, if you're using a pencil in the exam, rotate this then around. Now 90 degrees, of course, is that way, don't forget. Okay, so I'm going to rotate it 90 degrees. Oh, one thing I've forgotten is to trace the shape, of course, silly me. So make sure we trace the shape first, otherwise I'll be rotating my tracing paper with nothing on it. Okay, so rotate it round. Now 90 degrees means a quarter turn, right? So if you look at my axes, they're turning around. Okay, I can stop when the axis again is being formed. Okay, when the axis is formed, so you can see there that I've got quarter turn, right? So if I run that again. Okay, so there's your shape to start with. Okay, and rotate it round so that the axis is formed again, 1/4 turn, and I've got that there. Okay, so what I do then is, of course, I lift up the tracing paper, mark the corner points where they should be. Okay, and I've got my rotated triangle. And it says then to label that C. Okay, next one, it says describe fully the transformation that transforms triangle ABC into triangle PQR. Now this looks a bit of a mess, okay, but here we want the transformation. It's not a translation, right? It hasn't been translated, because remember, translated just means to shift, to move. Something else has gone on here. It hasn't enlarged, okay, it doesn't change size. And I wouldn't say it's been rotated neither. It's actually been reflected. Okay, and because the shapes overlap each other, okay, the reflection mirror is actually going in between those shapes. And quite simply, this is something we need to look at. Maybe we've got a reflection in the line y equals x. If I turn it around, look, you can do that. You can see there, that diagonal there. If I draw it in, it'll be even clearer to you. Okay, but that diagonal there, actually, you notice both sides now, they're symmetrical, aren't they? Okay, so it's been reflected in that line there. That line we call y equals x, of course. Okay, that's my y equals x line. So when we write down here, we need to say reflection. That will get you 1 mark, okay? And you need to say then in the line, make sure you have that down, right? Y equals x, okay? And of course you need that as well. Okay, question 3, sorry, it says the diagram shows the transformation of triangle A to triangle B. Describe fully possible transformation. Again, that looks like a reflection to me. Okay, so we need to write reflection, but most specifically, we need to say what it's been reflected in. What line has it been reflected in? Now, it looks as though it possibly could be the x-axis, but then again, if it was the x-axis, A is like further away. If you think about it, A is like 3 squares away, that line there, in the x-axis, whereas this line is only 1 square away. So the mirror is going to be halfway between these shapes, okay? If you think about it, the mirror is going to go about there, I'd say, okay? Let's put it there. So I can draw my line so that I've got I mean, the axes can sometimes put us off, this x-axis, but if you look here now, I've got now 2 squares there, yeah? I've also got 2 squares here. Okay? So, it's a reflection. Now that line, of course, that line goes through 1 there. Goes through where y is equal to 1. So, that's the line. Okay? And the line where y equals to 1. Part B then, it says rotate triangle A through 90 degrees clockwise about the origin and label it C. So it did say triangle A, didn't it? So I've got to make sure I rotate the correct triangle. So label the, do the axis like that. Okay, I'm just going to draw my tracing paper here. Okay. Now the question did say clockwise, yeah, about the origin. So clockwise, of course, is that way. Rotate it round until my axis is formed again. And there you go, there's my reflected shape. Okay, so I lift my shape up, lift my tracing paper up. And I've got my shape formed there. Okay. Okay, and then as my rotated triangle, it says to label it C. Describe fully here, the transformation again. I'm hoping you can see it's a reflection. Okay, reflection. Let's get the line right. It's not the y-axis clearly. The y-axis isn't in the middle. It's more like this line here, isn't it? Use a pencil, as I said. You know, you can rub it out. If you notice there, that's 3 squares. That's 3 squares. So the distance is the same. That line, well, it's going through 1 there, isn't it? Where x is equal to 1. So you say reflection in the line x equals 1. Okay, so we've got our answer there. We put down reflection. We said x equals 1. The last one, okay, this one, describe fully the transformation which maps triangle A onto triangle B. I hope you notice the different sizes. So in this case, it is an enlargement, yeah? And you will get a mark for just putting that down, an enlargement. The only trouble is, though, with an enlargement, you need to note where the center of the enlargement is, okay? So you need to work out where that is. With center, okay, where the center is. To work out the center is a really good way of doing it. All you've got to do is look at the corner points that correspond. So that corner point there corresponds to that corner point. Draw a line through both corner points. So that corner point that corresponds to this one, draw a line through it. Do the same then for that corner point and that corner point. Okay, the ones that correspond there. Finally then, these 2 corner points also correspond, so draw a line through them. What will always happen when you do this is that the 3 lines that you draw actually meet at a point. That point there is your center. So the center will be that coordinate there. So you go across 4 up to 11 from that. So the center will be 4, 11. Okay? To get the 3rd mark, you also need to say what the scale factor is. Okay? Now it says maps triangle A onto triangle B. So triangle A has gone to B. It's got bigger, isn't it? It's got bigger. It's easy to work out how many times bigger it's got. How long is that side there? Is that 3? I think that's 3 squares, isn't it? And then look at how long this side is. If you calculate, that's 9 squares. So going from 3 to 9, we've multiplied it by 3. So the scale factor is 3. Okay?